A ring of mass capital M and radius capital R is rotating with angular speed omega about a fixed vertical axis passing through its center O, with 2 point masses, each of mass capital M by it at rest at origin or at O. These masses can move radially outwards along the two massless rods fixed on the ring as shown in the figure. At some instant, the angular speed of the system is 8 omega by 9, and one of the masses is at a distance of 3r by 5 from O. At this instant, the distance of the other mass from O is 2r by 3, r by 3, 3r by 5, 4r by 5. Okay, so clearly this is a problem on rotational motion. So how many bodies do we have? Constituent bodies are 3. There is a ring. Mass capital M, radius capital R. Okay, it is rotating with angular speed omega about a fixed vertical axis. Okay. Now they are saying the mass is already rotating, but initially the 2 point masses are at rest. Okay. At t equal to 0, m by 8 are at rest, but more importantly they are at rest at origin. Okay. Now they do not specify what is causing the motion. Okay, but they say that these masses can move radially outwards along the two massless rods fixed on the ring as shown in the figure. At some instant, the angular speed of the system is 8 omega by 9. Okay, so system at some later t, the angular speed is 8 omega by 9, and one of the masses at a distance of 3r by 5 from O, at this instant the distance of the other mass from O. Okay, so we have to apply the momentum conservation here. Okay, we have to apply the momentum conservation here. Okay, see, because is there anything else that is producing that change or that is encouraging these 2 point masses to move radially outwards? We don't know. Okay, we don't know, but we know for sure that because the massless rods are rotating, okay, because these massless rods are rotating and the contact between the point mass and the rod is frictionless, right? Well, then you have to assume it because they have nothing said about it. Due to centripetal force, well, or I should say centrifugal force acting on them, they will start moving radially outwards. Do you agree?
Yes, sir.
Yes, sir. Okay, so we have to use, and that is an internal force, we have to use momentum conservation. So I'll say by momentum conservation. Okay, what is the initial angular momentum? It's a ring, so mr squared omega. What is the final angular momentum now? There will be 3 bodies now. First m r squared, moment of inertia will be same because axis of rotation is not changing, but its final angular speed will be 8 omega by 9. Okay, now one of the masses, its value is m by 8. Okay. Okay. It is at a distance of 3r by 5. So I'll say r squared into 9 upon 25. Right? 3 by 5 squared is 9 upon 25. And what is omega then? Omega is 8 omega by 9. Okay. So mr squared omega into 8 omega by 9. But that is only for one of the masses. Okay, that is only for one of the masses. Now we have to write down the same formula or similar expression for what? For the second mass, right? For the second mass. So how will we?
So,
Yes.
square omega into 8.9, not 8 omega.
No. Okay. Momentum. Okay, angular momentum is I omega, right? What is I? Mr squared for a point mass. Mass is m by 8. What is the distance? Distance is 3r by 5. So 9r squared by 25. That is I now. And what is omega? 8 omega by 9. Is that right? I just written the constants on one side. Or numbers. Okay? 1 upon 8, 9 upon 25 and 8 by... Oh, okay, you are saying this omega. Oh, okay. Sorry. Yeah, you're right. Plus, the other object also has mass m by 8. And it is also, okay, so we don't know x, so let's call it x, the distance we don't know. And its moment, its angular velocity is 8 omega by 9. Is that right now? Yeah, that's right. Okay. Now, m, omega will go. Okay. So what remains here is r squared equals r squared into bracket 8 upon 9 plus 8 goes, 9 goes, 1 upon 25 plus 8 goes x squared by 9. Okay, x squared by 9. That right? Yeah. Okay. Therefore, x squared is equal to 9 into r squared into bracket 1 minus 8 upon 9 minus 1 upon 25. Now 1 minus 8 upon 9 will be how much? 1 upon 9. So it will be 16, 25 minus 9, 16 upon 9 into 25. Okay, this 9 is cancelled by this 9. So x squared is 6, r squared into 16 by 25, so x will be 4r by 5. X will be 4r by 5, that is option D. Is that clear?
Yes, sir.
Yes, sir.
Yeah, okay. Now that question still remains unanswered as to why these two masses will be at unequal distances from the center at any given instant of time. Might be because this angle is not 180 degrees, but we don't know. Okay. We may express them as a function of theta, the total net angular momentum of the two bodies. Okay, net angular momentum of the two bodies. And yes, let us question it.